name is Jacob Ideskog. I work as an identity specialist or a solution architect or a developer or something of everything at Twobo Technologies. And we specialize in identity problems. How do you secure your APIs and your websites? And we think the solution to that is by focusing on the identity. And one of the things that we see a lot is that you couple your identity way too close to your API. And that brings out bad design. If your API has /getTree/Jacob, that somebody should show a tree about Jacob in there. That's bad. We try to avoid that. So today I'm going to talk a bit about that. But I'm going to roll back the tape a bit. What we really want to do is we want to solve a couple problems. We need to provide data. That's the essential problem we're trying to solve when we're building an API. And obviously, we need to do it securely. We need to make sure that the right person is making the call. So we need to answer this question, who made the call? But we also need to answer the question, what is the caller allowed to do? And the caller in this case could be both the client, the application, and the user who made the call. We need to know both. And this is, for you all probably know this, but this is called authentication and authorization. And is part of something called AAA, which also sometimes include auditing or accounting or something else. But I like to put auditing as the third A. And auditing means, what did you do? How do we know what you did? It's very important, especially when you have customer service calling you in the middle of the night and saying, this user says he logged in last night, but I don't know, did he? And auditing tells you, did he or did she? Auditing is the logs, it's the database records, it's all of the things we need to know. I'm listing it there for visibility because I want to have it in there, but I'm not going to talk about it so much. The second problem we want to solve is, how do we make sure we don't waste our resources? We heard about caching just now. Caching is great, but it still doesn't prevent people from making stupid requests to our server. So we need to make sure that when we execute our code pipeline in our API, do it for a purpose. Namely, that somebody who requested the data is allowed to read the data and is allowed to access whatever we have to provide. This is just some weird example of what it could be, but we have some SSL termination, some sort of routing internally of what we're doing, and then of course some logic, and then a database maybe in the end, maybe many databases that we call, and it would be really bad if it's here that we find out that, oh, you're not supposed to be here, you don't have access to this data, you ask for data that's not yours, or whatever. That's the kind of thing we want to move as early on in the pipeline as possible. Typically, you do that by putting something in front, like a proxy or a cache or something. And, well, that looks great, and it's simple like that. But how do you make sure that the proxy knows what to do? Like, how does it know? How does it know that you are you? How does it know that you are entitled to move on further down in the chain? That's the question we really need to answer. So we have three questions, actually. Who is accessing the data? What application is accessing the data? Is it mobile? Is it a server? Is it another web application? Or what is it? And is that user and that application allowed to access that data? In order to dive into this a bit deeper, I'm going to talk about OAuth. How many of you have worked or heard or read about OAuth before? Ah, good. Almost everyone. How many of you would say you know OAuth well? A couple, good. So there's something new maybe for someone in here. OAuth is an interesting protocol, but it doesn't do authentication. So what we're really trying to find out here is who is the user and what is the user allowed to do. OAuth can't answer that. It can't say who is the user because it doesn't know. Like, it can't authenticate you. Someone else has to tell OAuth who the user is. So essentially we have these guys. Typically you have 4 in OAuth. I added a 5th because it's interesting in this case. We have a resource owner, you, the user. we have a client, the application. This could be a mobile device, or it could be a server, or a web service, or a website. We have the authorization server. This is the OAuth server. And we have the resource server. So given a simple example would be that we have a mail server here. And we want the mail server to provide information to a cool app that lets me sort my emails in a better way. And in order to do that, the app needs to first, before it can access this, go to the authorization server and say, hey, can I access this API? I need to get some emails. And the authorization then says, well, I can't authenticate you. I have no idea who you are. Please let the user be authenticated. And that's when the authentication server or service or part comes in. So it delegates it actually to somebody else, because that's what OAuth is supposed to do. So the authentication service or server shows the user some sort of way of logging in, and the user enters its credentials. And when that's done, the authentication service says to the OAuth, great, you're logged in, the user has logged in, and the OAuth server issues a token. There's variants of these flows. It's a bit simplified, but that's what happened. This token, in turn, is then used by the client when it needs to access resources on the server. And in order to do that, the resource server also needs to know, so what's this token? What does it contain? Is it a user in there? Is it something in there? So it asks the authorization server, who then says, yep, this is Jacob who asked for it, and it was the client application mailer, and you can send the data, and the resource server responds with the data. That's OAuth in a nutshell, pretty much. So what we want to focus on now is three very interesting parts of this. We want to talk about the API, obviously, the resource server. We want to talk about OAuth, the OAuth server, but we also need to talk about how did the user log in here? How do we connect the dots? How do we make the complete picture? And for the sake of pictures, I switch icon, I realized after half my presentation. API is that now. So once again, what do we need to know? What does the API need to know? Who was requested access? Which application was requesting the access? It's good to know both, because if it's an iPad requesting it, we might want to formulate other responses than if it's a desktop asking for it. Want to add more metadata, for instance, for how to display it, or something. And are they allowed to? So if we step back a bit, how do you describe this type of information? And this is an old problem, and it's solved way back. It's called federation back in the days. How do you describe authentication between systems? Typically, it consists at least of these type of things. You have a subject, who logged in. You have an authentication time, when did that happen? And you have something called an ACR. How did that happen? How did the user log in? Was it with some social login, or was it with username password on the local account, or was it with Kerberos? Or ACR means authentication context class reference, so that's why I don't type it out, because it's very long and weird. So with this, we solve the problem, right? We just tell the API, okay, now you know subject, you know when that happened, and how it happened. And that would look like this. The authentication server would tell the OAuth server that you have a subject, that's Jacob, you have an ACR, that's social, and you have an auth time that's pretty much now, epoch-wise, and then we create an access token and send it to the client with that information in it. With the API then, when it gets the token in the end, would it simply look at the ACR and deal with it? Be like, okay, so I saw something in there, and I'm gonna now act and give the appropriate resources based on that. That would look like this. If the authorization server and the authentication server in turn delegated to Google. So when you came to authentication, what really happened is you switched window, and that Google pop-up showed up, and you entered your hopefully two-factor authentication on Google when you logged in and returned back, and then that in turn rolled back and became a token. that would in essence mean that your API actually has if you told the API that, here's the ACR, it was Google, you would have a direct dependency to Google from your API. And that means that you can make assumptions on what that information is, right? You can say that, okay, it's Google, I know that the user ID has this form, I know that I can find the email address in this way, and the email address is really a something something, and the two-factor information is somewhere else, and you make a lot of assumptions around what happened because you knew it was Google. And then your manager comes in and says, no, we're going to use Facebook actually this year because Google is so yesterday and only enterprises use it, so we want to be cool kids now. And then you cannot do any of these assumptions anymore because Facebook does it differently. They don't even use exactly the same standard. And, well, you have 150 of these deployed. We have a customer, I think they have 175 running microservices deployed at all times. It's a lot of work. And it gives you a lot of headache when you need to do this. So what we really need to do now is we need to split this apart a bit and make the abstraction not only good, but also standardized. And luckily, there's a solution for this, of course. We need a wall between the API on one end and the OAuth server and the authentication server on the other end. OAuth plus authentication, if you spice OAuth with a service of authentication, that will give us the tools. And as you can see, I'm not writing any standards around authentication. You might be thinking, why aren't you writing OpenID Connect here? Well, I'm not really meaning OpenID Connect, and we can debate on that afterwards. I'm meaning authentication, like how do you log in specifically? And there is no standard for that. It's impossible to standardize. One authentication could be you enter your PIN code and enter a door, and that triggers you to be logged in on a screen. And another authentication could be that somebody phones you and you reply with a voice code. There's no standard that can combine those two. It's impossible. But we can use the concept nevertheless. So if we remember what an authentication looked like from the federation world back in the days, OAuth defines its tokens or its information about the user quite differently. It says, in an access token, roughly, there is a subject, who the user is. There's a client, who the application is. This isn't always there, but we recommend you always to have it there. There's a scope, and there's an expiration. An expiration, of course, the access token is only valid for so long, then you need to get a new one. This is a control mechanism in OAuth, which is a talk in itself, very useful. The scope, though, what do we do with that? The OAuth scope is something you probably have heard of, seen, and used many times. If you've seen this thing, it doesn't look like that anymore, but it did back in the days of Facebook. This is OAuth. They define like when you logged in with a new application on your phone or on your iPad, you got this and saying, this application is now requesting access to do this for you. It wants to post on your wall, it wants to manage your events, yada, yada, yada. This is scopes. So scopes are kind of like permissions in a way. They are specifying what the token is for, what you can use it for. They are listed on a consent UI, not so much always, but it happens. That's where you see it at least. And there's no standard for it. It's whatever you want it to be, which is extremely useful because it's also hard to fall out. So let's design something. We have an API. We call it articles or /articles. And we're going to do a couple things. We want to be able to read articles. We want to be able to read premium articles. We want to be able to write, in a sense, add, delete, and update articles. So how do we transform this into permissions? Well, that's not very hard, is it? We create a couple scopes. So we say, we have something called articles regular read, articles premium read, articles write. Or if we're building a more fine-grained service, we may have articles update or articles create or delete, depending on what we're trying to do. I'm visioning this very useful API as something like it's a newspaper and every customer is reading and every employee is writing. So therefore, the write scope is a good choice, I think. So let's build an application then on the other end. We call it Article Reader. And in OAuth lingo, that's a client. And the client then needs to be assigned which scopes it's allowed to get. Doesn't mean necessarily that it will get those scopes. So articles regular read and articles premium read are the scopes that it can get. It's a reader client. It can't write. Impossible. So here comes the magic. We assign these scopes with different strength. And we say that if you want articles regular read, we consider that to be a weak scope. You can log in with any social authentication you want. If you want articles premium read, it's less weak, but it's kind of weak. But you have to be a customer. So you can log in with a social authentication, but we have to look you up and make sure you're a registered customer. Paying customer, probably. And articles write, it's a strong scope in a sense where user is an employee, and we probably verify that by you not logging in with Facebook, but probably with integrated Windows authentication or the username password that exists in our LDAP directory, or we check a role, or whatnot. And then we let the OAuth server filter these scopes. So, say that we have this example. We want to access the articles API, and we have an article reader, but the scopes that we request is articles. I didn't define that before, because I now want to show you some magic that OAuth can do. OAuth doesn't necessarily say that you have to give the same scopes you're requesting. It says that you should give scopes back, maybe, but if you do, you should tell the user which ones you did. So if you change the scope, you need to tell the user or the client. And that's what we're going to do. So we're sending that we want some articles, and we're an article reader. And then the OAuth server says, cool, but authenticate the user. The user authenticated with Google. Something popped up, it single signed on, boom. The authentication server bundled this together and said, that was social, nice, the user is Jacob, good. The authorization server now needs to check, well, is Jacob a customer? I know it's social ID, and can I map that to anything? Well, luckily, it could. So then it can decide, okay, let's issue articles regular read and articles premium read as the scopes. Which means that now that we fire an access token down to the resource server, we know a whole lot of things in there without knowing that it was social. Because the article app was calling, that was in the access token, as we saw before. The user, well, Jacob, that's already in there too, so the API doesn't have that in its path, it can just look in the token. It knows that it can serve regular articles, but it also knows that it can serve premium articles. So we have decoupled authentication and even some authorization actually from the API. So back to this problem then. Well, obviously, now that we have a proxy and we have our version of an API here, we can, of course, let the proxy allow access if these three rules apply. Token exists, token is valid, expiration hasn't happened yet, that is. Token contains one or more of the following scopes. We don't need to know exactly which one. We could, if we wanted to, like you're going to that subpath and then you need a premium scope, but we don't need to. We can block enough access already here. So we can know that you're a freebie user, you don't have any scopes, you should go to the freebie API on the other end, but all our registered users, they can go in this way, and we can block it already in the proxy, maybe even in the cache, I don't know. So, to conclude this, I propose that you separate the API from authentication. It should have nothing to do with that. That's how you build scalable API infrastructure, especially for microservices. Use the scopes then. That's standards. There's a lot of useful ways to use those in OAuth. and they're just coming to be popular as we speak. And define the scopes in the API. The API knows what it wants. So when the API designer says, this one should be able to do read and write, and I call it articles, then the designer has a pretty easy job of saying, okay, articles read, articles write, 2 easy scopes. If you end up with 15, 20 scopes, you're probably overdoing it. You want to do something in between. There are, of course, more advanced use cases. And then in the end, protect your APIs. That was it.
Excellent talk.